In the northeast region of New Brunswick, there's a river called Nepisiguit. The Nepisiguit was once renowned as one of Atlantic Canada's premier salmon fishing rivers. Community groups, industry, and government have been combating the ravages of overfishing, poaching, and pollution. These days, anglers on the river are happy. They've seen the salmon population increase from a scant 300 adult salmon 10 years ago to more than 6,000 today. The idea of restocking the river has been the primary goal of the Nepisiguit Salmon Association. Bob Baker has been president of this non-profit group since its inception.
Well, basically our association was formed in 1976, and shortly after we formed, we began to look at ways that we would be able to increase the salmon population in the river. And first of all, we worked through Department of Fisheries notions in order to ensure that some stocking would take place. And eventually we participated in that stocking ourselves to some extent, and then we went on in 1981 to start our own enhancement program up with the cooperation of the Department of Fisheries notions and through a job development program with CEIC.
Preparation began for stocking, using Nepisiguit River broodstocks. This entailed collecting and transporting migrating salmon to the hatchery. Brunswick Mining and Smelting Corporation, through the Noranda Technology Center, offered help with the projects. They made available the use of their pickup truck to transport the salmon hatched at the Charlotte Fish Culture Station to the river. They helped put up a fish counting fence, assisted with electro-fishing, transported spawners from the river to the fish station. But it was in 1984 when the project took a leap forward. Craig Wood, a Noranda Technology Center biologist, had developed his idea of how to allow public groups to participate in salmon enhancement programs. He believed that community groups could be directly involved in increasing the salmon population in the river system. In turn, the hatchery would expand beyond its physical boundaries. Apart from space limitations, there was the question of keeping the eggs and fish as close to nature as possible. At the hatchery, the eggs are hatched in indoor tanks and incubators. For the most part, the young salmon, called fry, are fed to a certain size, then released into the river system. In Craig's idea, some of these activities would be moved right to the riverside. On behalf of Brunswick Mining, Craig did research on the existing salmon enhancement technologies. To get closer to nature, the eggs would be matured and hatched in the actual river water, and the young salmon would maintain their survival instincts as if they'd emerged from the riverbed. Craig wanted to provide technical assistance to the Salmon Enhancement Program and develop the program together with the Nepisiguit Salmon Association and the Department of Fisheries and Oceans. He prepared a proposal to field test streamside incubation boxes, something done extensively in the West. The idea was presented. They agreed to do a study. The first job was to find a suitable test site on the river system. Craig looks back at how it all started.
We had to find a site that would provide us with good water flow, good water quality, and virtually isolated so we would be away from any tampering of any kind.
It was important that natural river water run through the incubation boxes to keep the fertilized eggs alive in an environment as close to nature as possible. They were looking for a site to run the system by gravity, near a waterfall to provide sufficient water supply to the box.
We found that site located on the Pabineau River It's in about 1.5 miles from the road. We had to walk in. It's a site that you don't drive to. We had to create the trail. We got into the site. We found a nice set of falls. We had a nice pool in the top of the falls where we could put in all our plumbing system. So in the fall of 1984, we went about our business of putting this whole system together, which meant carrying in all the piping, all the supplies, the concrete blocks, the big metal tanks to protect the incubators, and set the whole system up. We did the site preparation of moving rocks around, putting in the piping up at the top of in the pond, doing all the plumbing, ensuring that everything was up to what we figured would be a good scientific study.
The whole project was based on using what are called eyed eggs that would be supplied by the hatchery. The advantage of using these eggs is that they're not as sensitive as less mature eggs. They're very resilient and easy to transport. During the spring run of salmon, the Nepisiguit Salmon Association collects fish suitable for broodstock from their counting fence and maintains them at the hatchery until the males and females are ripe and ready to spawn. The eggs are extruded and fertilized at the Charlotte Fish Culture Station in late October, early November, and remain there until late April. The adult salmon are released back into the river system in late fall. By April of 1985, Craig and members of the Salmon Association set up the system at the Pabineau River site. Their goal was to test it with about 26,000 eyed eggs in the incubator, about half its capacity. In early May, they loaded the box with layers of eggs on poultry nesting, which resembles astroturf.
In the spring of 1985, we loaded the incubation box with approximately 26,000 eyed eggs from the Charlotte Fish Culture Station. Each layer had 2,600 eggs spread out across the poultry nesting. We put some rocks down to hold the poultry nesting from floating, placed another layer of poultry nesting, and continued doing that, putting eggs, rocks, and poultry nesting until we had 10 layers. And then the top 2 layers would have no eggs, just to protect the eggs from sun. They're photosensitive, so we want to keep the sun out.
The mats were positioned to allow the best flow of water through each layer. They put in a submersible thermograph, which is a recording thermometer that gives water temperatures over time. They also maintained a constant water flow through the box. The flow rates, river and box temperatures, and oxygen levels were checked and logged every day from the beginning of May to the 4th of June, when the young salmon were ready to come out of the box. About a week before the newly hatched fry were ready to swim out, a fry trap was set up to collect them. A screen in the incubation box was removed to allow the fish to escape into the trap. During this period, called fry emergence, Craig and an Nepisiguit Salmon Association member counted the number of young salmon that came out.
Once the fry were collected in the fry trap, then we began the process of counting and measuring the fry. And this involved, because it was a research project, we would count each individual fry that came out of the incubator.
More than 26,000 salmon fry were counted. The layers of poultry nesting were removed and checked for dead eggs and dead fry. During the emergence period, they wanted to know total survival, and the results were very encouraging. The survival rate was 98%, and that's 3 to 5 times as high as the normal survival rate in the wild. The fry were released in the Pabineau River near the incubation site. Their first instinct was to bury into the gravel to begin to search for food. In 1986, the process was repeated, this time using 50,000 eggs, 5,000 on each layer, or full capacity. The results, again, were very good. While the survival rate was slightly less, it was comparable. Over 96% of the eggs hatched to the fry stage. These fry were also released into the Papineau River downstream of the incubation site. The experiments were so successful, Craig and the Nepisiguit Salmon Association wanted to go to a full-scale production unit immediately. The only problem was their space limitation and volume of water. Only one box could be run at the Papineau site, which was not accessible by road. The search for a location that fulfilled all their requirements and one that could accommodate more incubation boxes ended at the Consolidated Bathurst Powerhouse Dam at Grand Falls. A series of tests were conducted on the Nepisiguit River at this particular location before the final decision was made. Craig had some concerns about oxygen levels, water pressure, and manganese levels. Manganese, a type of mineral natural in the river, is very detrimental to fish. Another concern was the vibration created by the 3 turbines at the powerhouse. The water and vibration levels were studied and found to be fine. Consolidated Bathurst was more than willing to assist with the project. They provided the location, access to the dam, and helped put in a water line. 3 incubation boxes were set up at the site. The water line was run off an emergency fire hose supply line. A system that consisted of a degasser, which is a large diameter pipe with a series of chambers filled with plastic rings, was constructed. A degasser strips out any excess nitrogen from the water and adds in oxygen by subjecting the water to the maximum amount of surface area. They did this because nitrogen is deadly to small fish.
Hang on there, okay?
3 incubation boxes, each filled with different densities of eyed eggs, 40,000, 50,000, and 60,000, were loaded in May 1987. The same experimental setup was done at the Charlot Fish Culture Station. This was done to test and compare survival rates at different densities to determine the optimal loading density of the incubation box. Survival rates were over 95% in all cases. In 1987, the Salmon Association and Craig Wood, on behalf of Brunswick Mining and Smelting, released more than 140,000 fish into the river system. These fry were not counted one by one. They did volumetric counts, checking every 5th one by hand. The survival rate of the fry, once they leave the protection of the fry trap, is in the hands of Mother Nature. The work and documentation done by Bob Baker and his association's members, however, is helping to determine the success of the program.
Basically, the counting fence is the cornerstone of our enhancement program. At the fence, which is set up each year towards the end of May, we record the total number of fish passing through the fence, whether they're grilts or salmon. We take scale samples off a representative sample of the grilts. Off the salmon, we take scale samples off each one, which will allow us to find out how old each fish is, how long it spent in fresh water before it went to sea, how many years it spent at sea, and how many times it has previously spawned. We also measure and weigh a good portion of these fish to get an idea of the size differential between them. We also collect broodstock at the fence for transfer to Charlot Fish Culture Station. Now, these broodstock are all early run fish because that is the segment of the run that we're trying to build up.
The salmon that pass through the fence are en route to their spawning grounds. Like BC salmon, Atlantic salmon return to the river where they hatched to spawn.
The difference between the Pacific and the Atlantic salmon is mainly in the fact that the Atlantic salmon do not die after going up to spawn the first time, as do the Pacific fish. The Atlantic salmon usually lives for about 2 years in fresh water before it goes to sea the first time, and then it will spend 2 years at sea before returning to spawn as an adult fish weighing 10 pounds or more. And fish that are in excess of 25 pounds are invariably fish that have previously spawned at least once before. In 1988, we had a fish at the fence that weighed approximately 50 pounds and was spawning for the 4th time. That fish would have been approximately 12 years old. Pacific fish spend very little time in fresh water, 3 or 4 months, then they head to sea, spend the most of their lifetime in the sea, and they return once to spawn, whatever size they are, and they die after spawning. So we have a very renewable resource in the Atlantic salmon.
All of the information gathered at the fence is documented for each and every fish, and only fish that are in prime condition are selected as broodstock to keep at the hatchery. While they can't mark the fry that are released into the river system for future monitoring because they're too small, the increasing numbers of salmon going through the fence year after year indicate their success.
In terms of what stocking can do for the river, it's quite evident at our fence each year, because in 1981, when we first started our fencing, we counted 312 fish. In 1988, we counted 4,350. So that's quite an increase over a 7-year span.
And that number was only the fish counted at the fence. The actual estimate of adult fish returning to the river was 6,000 in 1988. With excellent results from the experimental stage of the streamside incubation program up until 1987, the Nepisiguit Salmon Association was ready to take charge of the program and move it into full production scale at the dam. In 1988, the goal was to transfer the technology to the Salmon Association. Essentially, they completed the setup of the installation and increased from 3 incubation boxes to 6, which would hold about 300,000 eggs. It was basically all run by the Salmon Association, with some participation by Craig and Brunswick for the setup and fry distribution. Because of the consistent survival rate, fry were no longer counted. Eggs that never hatched and dead fry were counted. The difference is what went out into the river. The Salmon Association, proud of their success, invited the Boy Scouts to witness fry emergence at their first production unit. The most recent production unit has 7 incubation boxes that will house 350,000 eggs. The streamside incubation box technology expands the capacity of the hatchery, which becomes a very large egg incubation facility. The Salmon Association takes it from there. While the process has been streamlined over the years of development, it is by no means an easy task. Transporting the eggs and loading the boxes takes a lot of care and a lot of time to check progress as the eggs develop. The mass pandemonium sets in when the fry start to hatch. They can't sit in the fry traps too long. They have to be put into the river. But the Salmon Association members are enthusiastic about the program and await the fry emergence eagerly. After all, the more fish that are stocked, the better the angling seasons will be in the future, which is their ultimate goal.
Now that we have proven this method is to be very successful, we are also able to transfer this technology to other salmon groups within the province. And there are now, I believe, at least 3 other groups that have an incubation box set up going this year. And this is all based on the success that we had. So they've been able to go ahead with this. They don't have to do the research to prove it. It's already been proven.
The Salmon Incubation Box project, initiated on behalf of Brunswick Mining and Smelting, has created a pace of its own. Success and a feeling of cooperation from all groups continue to feed the enthusiasm of everyone involved.